Welcome to my channel kcse revision form 3. Today we are looking at the extraction of saliva. So we have the diagram below shows the extraction of saliva by the Franck process. So we have the grout surface, then we have A, pipe B, then we have C. You are supposed to state the uses of pipes A, P, and C. Give 2 crystalline allotropes of saliva. Write an equation for the combustion of saliva. Name the product formed when a mixture of saliva and iron is heated. Name impurities found in saliva. State the physical properties of saliva that makes it possible to be extracted using the above method. State 2 uses of saliva. We have 6 dm cubed of sulphur were oxidized by oxygen to sulfur 6 oxide. Write an equation for the reaction. Calculate the number of moles of sulfur and oxygen used at room temperature and pressure. Then finally, determine the volume of oxygen used, where we have been given the molar gas at room temperature and pressure is 24 dm cubed. So follow me as I navigate and unpack and do analysis on this question. Crickles Boys High School. Follow my channel, Marida James. Kindly subscribe and click the notification bell such that you will be notified once I upload a new video. So in this diagram, we have it shows the Franck process, the extraction of saliva. We need to know the purpose of pipe A, pipe P, and then we have pipe C. So first of all, you have this is the methods of extraction of saliva is called the Franck process. This one involves the 3 concentric pipes of different diameters which are drilled into the saliva deposit underground. So we have the 3 concentric pipes. We have this is the innermost pipe which has been drilled, the saliva deposit. We have the second pipe, and then of course we have the middle pipe. All of them, they are drilled into the saliva deposit. So this is where we have the saliva deposit. So in the innermost pipe, you can see we have a hot compressed air. So we have a hot compressed air which is passed through the innermost pipe. Then the outermost pipe, we have a superheated water under pressure, so which is passed through the outermost pipe. Then we have the molten saliva and water mixture. It is now coming out through the middle pipe. Now at the outermost pipe, we have a hot compressed air. We have a hot compressed air which is compressed at 15 atmospheres. So we have a hot compressed air which is compressed at 15 atmosphere, and it is forced down through the middle pipe. So this the hot compressed air is forced down through this middle pipe, which is the purpose of this hot compressed air. It is to force the molten saliva up through the middle pipe, so that it is purpose. So we have it forces the molten saliva through the middle pipe. We have a hot compressed air which is forced down through the middle pipe, and its purpose is to force the molten saliva up through the middle pipe. Correct. We have the outermost pipe where we have the superheated water. A superheated water which is heated at a temperature of 170 under 16 atmosphere is passed through the outermost pipe. What is the role? What is the purpose of this superheated water at this temperature? So the role of the superheated water is to melt the saliva underground. So we have this superheated water through this pipe. So we have the saliva deposit. So it is purpose, it is to melt the saliva underground. Then we have the outermost pipe. So once this, now we have the saliva which has been melted here. Saliva is purified through the sublimation and the yellow supplement. So we have saliva is purified through sublimation and a yellow supplement as flowers of saliva. So why do we maintain water at the temperature which is above 100? Why do we maintain this temperature? So the water is maintained in a liquid state at this temperature above its boiling point because it is heated under pressure. So that is why we are maintaining, the water is maintained at a liquid state at a temperature above it is boiling point because it is heated under pressure. So we can have that saliva comes out. So you can have saliva is now coming out through the outermost pipe. So it is coming out through the outermost pipe. So we have the three concentric pipes, the hot compressed air, the superheated water, then we have the molten saliva. Now, what physical properties that makes it possible this saliva to be extracted by this method? What makes this Franck process possible to extract saliva? So one, saliva, it has a low melting point. That is the physical properties that makes this method very, very possible. So the density of molten saliva is lower than that of water. That is another physical property. Molten saliva is immiscible or is insoluble in water. It is immiscible or insoluble in water, a property that makes it possible to be extracted by this method. Because if you put the superheated water, one is melt the saliva, molten saliva, and water do not mix. They form heterogeneous mixture. So they are immiscible, they do not mix. So impurities found in saliva, you can have the soil. So sometimes you will be asked to name impurities which are found in saliva. So we have the soil, we have sand, you have silica, and then you have clay. So these are the impurities which are found contaminated with saliva underground. Now, we have the chemical property that will make saliva to be extracted by this method is only one. It does not react with water. It does not react with water. It forms two layers. It is immiscible. It is insoluble in water. But now the one chemical property that makes saliva to be extracted by this method, it does not react with water. Now, let us now come back to our questions that state the uses of pipes A. The pipes A. So in pipe A we have hot compressed air. So we can have this one as hot compressed air at a pressure at 15 atmosphere is forced down. Down. Then pipe P, the hot compressed air forces the molten saliva up through the middle pipe. So the hot compressed air forces the molten saliva through P. So this is the middle pipe. So we have molten saliva out. So here we can have molten saliva. Then we have C, a superheated water under 15 atmosphere is passed through. So we have a superheated water. pipetted water at 170 degrees under 16 atmosphere pressure is passed down. Correct. Now state two crystalline allotrope sources of saliva. There are two. We have rhombic saliva, then we have monoclinic saliva. Write an equation for the combustion of saliva. This is where saliva combines with oxygen is formed saliva oxide gas. So we have saliva combining with oxygen. So and this one gives us a saliva 6 oxide. Not saliva 6. So we have this one as saliva 4 oxide gas. Name the product formed when a mixture of saliva and iron is heated. You know, when you are heating if you have the saliva reacted with an iron, so you could form iron 2 salivate, and this one here it is black. You have this a black solid. So name the product formed. So the product is iron 2 salivate. We have iron 2 salivate. Name the impurities found in silver. Name the impurities found in saliva. We have clay, we have sand, we have silica, and then we have soil. So you can name any. So we have soil, so you can name soil, or you can name sand, or you can name silica, or you can name clay. So these are the impurities which are found in saliva. So we have sand, we have soil, we have silica, and then we have clay. State the physical property of saliva that makes it possible to be extracted using now the above method. So the physical properties, it has a low melting point. So here you can have low melting point. You have low melting point. Saliva is insoluble in water. It is immiscible. So we have insoluble in water, or it is immiscible in water. Then you can also write that molten saliva is immiscible with water. Is immiscible with water. So, or you can also say that the molten the density of molten saliva is lower than that of water. Is lower than that of water. Now we are supposed to name two uses of saliva. Saliva has a wide uses. You can talk of vulcanization of wrapper. Vulcanization. So we have this is a vulcanization of wrapper. It can also be used in the manufacture of sulfuric acid. Manufacture of sulfuric 6 acid. You can also be used as a fungicides or the manufacture of insecticides. A sixth dm cubed of sulfur oxide were oxidized by oxygen to sulfur oxide gas. Write an equation for the reaction. So when sulfur oxide gas is oxidized to sulfur 6 oxide gas, it's an equation, is a reaction which takes place in the catalytic chamber with the three optimum condition, and that is a temperature of 450, pressure of 2 atmosphere, and also vanadium catalyst. So a lot of heat is being generated. So we have sulfur oxide gas combining with oxygen. We have now sulfur 6 oxide. The reaction is high exothermic. So can correct. Calculate the number of moles of sulfur. Calculate the number of moles of sulfur oxide and oxygen used at room temperature. So first of all, we need to have moles of sulfur. So we have moles of sulfur oxide is equals to P. Moles is equals to P. We have sulfur is we have sulfur. We have this one mass over molar mass. So we have sulfur oxide gas, which is we can have this one as a 6, which is a volume. So we have this is a volume. You divide it by volume, molar volume of the gas, which is 24. So you divide this one by 24. Yeah, so if you put this one on the calculator, this one gives us 0.25 moles. From our equation of reaction, we have a mole ratio of 1 to 1, and then we have 2. So the moles of oxygen, so if 2 moles of this one, we have 2 moles of sulfur oxide producing this one. So we have 2 moles of sulfur oxide produces 0.25 moles. So 1 mole is equivalent to 1 times 0.25, then you divide it by 2. So from our calculator 0.25 divided by 2 is giving us 0.125 moles. Then lastly, we have determine the number of determine the volume of oxygen used. We have molar volume of a gas at room temperature and pressure is 24. So from here we have that 1 mole of the gas. So 1 mole of oxygen gas produces 24. So 1 mole of the gas produces 24.0. This number of moles, 0.125 moles, will produce 0.125 times 24, and then we divide by 1. Divide this one by 1 from our calculator. So we have 0.125 times 24, and this one gives us 3. So we have this one as 3.0 dm cubed. Correct. Follow my YouTube channel. Kindly subscribe.